continue with relational operators. Relational operators are essential in programming for comparing values and making decisions. These operators help determine relationships between numerical values such as equality, inequality, and greater or less of comparisons. There are two main categories of relational operators. The first one is comparing magnitude, the second one is comparing equality. Comparing magnitude, we have greater than. It checks if one value is larger than the other. Then we have less than, checks if one value is smaller than the other one. Greater than or equal to, check if a value is larger or equal. Then we have less than or equal to, check if value is smaller or equal. Then we have comparing equality. We have this symbol equal to, check if two values are the same. Then we have not equal to, check if two values are different. Key concept. These operators work with all numerical types, including int, double, float, char, but not with Boolean values. Relational operators return Boolean values, which means true or false, which makes them perfect for decision making in conditional statements like, for example, if, while loop, and for loops. Okay, so these are some examples that we can find here. 10 is greater than 5. Yes, true. Okay, and here we are checking the ASCII code, right? We have A and B. That's why it's true. Then we have 50 is equal to 50. True. Both values are equal. Then we have 20 is not equal to 15. True. Common mistake. Comparing different types. True is less than 5. This is a Boolean value and this is a numeric value. It's an integer, right? So integer invalid as a Boolean cannot be compared with an int. Comparing primitives using these symbols. Java allows you to compare all primitive data types using equal to and not equal to. It returns true if two primitive values are equal, otherwise it returns false. Not equal to returns true if the values are not equal, otherwise false. These operators work with numeric types such as byte, short, int, long, float, double, and char, and Boolean types, true or false. Okay, let's continue with our code demonstration. Let's initialize a variable code num1 value of 10, then num2 value of 20. Okay, so I have created this so I don't have to type in front of you because it's kind of boring for you. Okay, we're checking first greater than. Okay, so num1 is greater than num2. Okay, so 10 is greater than 20. No, this is false. Okay, then we have num is less than 20. Just this is true. Okay, we have number one. I'm sorry, num1 is greater or equal to num2. Okay, 10 is greater or equal to 20. It's false. Okay, then we have num1 is less or equal to num2. This is true. Num1, this is true. Then we have num1 is equal to num2, false. Finally, we have num1 is not equal to num2. This is true. Okay, let's see this in action. Let's print this. Okay, false, true, false, true, false, true. Okay, this is correct. Let's continue with the other example, comparing floating points. So now we are going to compare floating points. Let's say price 1 will be 50.5, and we have price 2 will be 50. Let's make it the same, right? Okay, 50.5. Okay, and we are going to print price 1 is equal to price 2. Okay, price 1 is equal to price 2. We will get a true here. Then price 1 is not equal to price 2. This is false. Okay, let's print this. Okay, let's print true and false. Yes, that's correct. Okay, let's continue comparing char values, because we know that we can compare char values. Okay, letter A, the value, the ASCII code of this is 65. Then we have char letter B, and I'm sorry, B, the ASCII code for this is 66. Okay, so A is less than B. Okay, letter A is less than letter B, so 65 is less than 66. Okay, it's true. Okay, letter A is less than letter B. This is true. Okay, let me comment this, and we're going to print. We'll see true. Okay, true. And let's continue with logical operators. They are used to evaluate multiple conditions that return a Boolean value, true or false. These operators help you make decisions based on the evaluation of multiple expressions in your code. Three key logical operators. We have and, of not. Returns true if both conditions are true, or returns true if at least one condition is true. At the end we have not. It reverses the Boolean value of a condition. True becomes false, and false becomes true. Okay, here we have a real life example. Case 1, the manager requests promotion if customer is extremely happy with the manager and you think deserve a promotion. So both conditions must be true in order to get that promotion. Then we have the case 2, students accept your proposal if you get a handsome pay, you get a lot of money, or the work profile is awesome. So one of them must be true in order for you to decide if you take the job. Let's continue with our code demonstration about logical operators. Let's create a variable called A with a value of 10. The other one we call B with a value of 20. Okay. Let's see this. We're going to create a Boolean variable called result, and this result will A is greater than 20 and B is greater than 10. Okay, let's see this in action. Let me take this one here. Okay, so A is greater than 20, A is 10, 10 is greater than 10, the 20, this is false. Okay, this is false. Let's continue with the other expression. B is 20, 20 is greater than 10, it's true. However, for this operator to work, we need both of them to be true, otherwise it will be false. So at the end we get false. Okay, if we print result, we'll get false. False. Okay, let's continue. Let's create another variable called result2, and we are going to paste the same. However, this is not going to be and or. Okay, so we know that this is false, false, or we know this is true. One of them must be true, so the condition is true. We print this. Okay, let's print result 2. We get true, true. Okay, let's continue with the other one using not operator. Let's create a boolean variable called result 3, and that goes like this: b is greater than 10. Okay, let's see this. b is 20. 20 is greater than 10. True. This is true. However, we are negating that, so it becomes false. We print result 3. I don't want to see this. We are going to comment this. We'll get false. Result 3, false. Okay. Let's continue with the other one using not operator with a false condition. Okay, I will create a boolean variable called result 4, and it goes like this. It's going to be kind of similar. A is greater than 20. Okay, A is 10. 10 is greater than 20. False. False. However, we are negating that, so we will get true at the end. We print result 4. We see true. True. Okay, let's continue with the other one. Using not operator with a boolean value. Let's create a boolean variable called is Java fun. We're going to initialize with true. Okay. However, we are going to switch that value. It's Java fun. So now we are going to see false in here. Okay, I don't want to see this. False. Operator precedence. When you use multiple operators in one expression, the order of operations, operator precedence, decides which part are calculated first. For example, expression. We have int, modulo, int2, multiplication, int3, add 1 divided by 2. Okay, how it's evaluated step by step. Modulo comes first. Then we have multiplication. Multiplication happens. After that, division happens. Finally, addition is calculated. Okay, without parentheses, operator precedence will follow the order mentioned above, and the result will be 300.